So then we're going to jump into problem 18. Problem number 18 says you're making a mural of the city of Hoffman Estates. The city of Hoffman Estates is about 11 miles long. Every mile of Hoffman Estates is represented by 3.5 centimeters in your mural. How long will your mural be? Well, the scale is for every 1 mile, we have 3.5 centimeters. So we would put the 3.5 centimeters on top, and we would put the 1 mile on the bottom, set it equal to X because we don't know how long the mural is, over 11 miles for the length of the city of Hoffman Estates. Then we're going to cross multiply, and we get X equals 11 times 3.5, which equals, let's see here, 3.5 times 11 is 38.5. So we have 38.5 centimeters is the length of the mural. Okay. Then we're going to jump into problem 19, and number 19 has been a problem that's kind of difficult for everybody. So we have a scale drawing of a kitchen floor with a scale of 1 unit for every 2 feet. And it wants us to name the dimensions of the original kitchen floor. Well, this is the scale drawing. Sorry, that's a really bad W. Drawing. Okay. So this picture, this square right here is our scale drawing. Okay. And the length of the scale drawing is 1, 2, 3, 4, 5, 6. And the width is 3. Okay. So this is the problem where we have to do model over actual twice, because we have to find the length and width of the actual kitchen floor. So we're going to start by using our scale for both. We have 1 unit, and I'm going to zoom in here. So we have 1 unit over 2 feet equals, I'm going to start with the width. We have 3 over X. So I'm going to put a W here so we know it's for width, and this is an L for length. Okay, we're going to cross multiply, and we get X times 1, which is X, equals 3 times 2, which is 6 feet. So this is the width. And then we're going to use the same scale, 1 unit for every 2 feet, and set it equal to 6 over X to represent the length of the actual kitchen floor. Cross multiply again. X times 1 again is X. Set it equal to 6 times 2, which is 12 feet. So this is the dimensions of the actual kitchen floor. Is 6 by 12. Okay. Then we have to redraw the scale drawing using the scale 1 unit for every 6 feet. And we have to use this info that we just found to do that. So it's almost like you do the work to find the actual dimensions, and then you have to work backwards again, like as if you're taking the actual dimensions and drawing a new scale drawing. So again, we're going to do model over actual twice. 1 for the width, 1 for the length. And we're going to use the new scale, 1 unit for every 6 feet, and set it equal to X over 3. Oh, sorry, not 3. That was the width of the original drawing. It's going to be X over 6 for the width of the actual floor. So we have 6 times X, which is 6X, equals 6 times 1, which is 6. We're going to divide by 6. And we're left with X equals 1 unit. So we know the width is 1. And then we're going to use again 1 unit over 6 feet equals X over 12. Cross multiply. We have 6 times X, which is again 6X. And set it equal to 12 times 1, which is 12. Divide by 6 one more time. And we get x equals 2 units for the length. So then our scale drawing is going to be 1 by 2, which looks like this when you draw it. Okay. Jumping on in, you were asked to draw a cross section for each 3D figure and list the 2D shape that resulted. So this can kind of go either way. So for number 20, so you had two of the same shape, and you had to make two different cross sections for the shape. So the first one, you could have cut the pyramid this way, and you would have had a square cross section because of it would have mimicked the shape of the base. Or you could have cut it this way, which would have resulted in a triangle cross section. Okay. So again, you could have cut the cylinder straight down. That would have made a rectangle cross section. And again, some of these you just kind of have to visualize. So if we imagine we cut this open and pulled it apart from the rest of the cylinder, we would be able to tell that the inside of the shape would actually look like this. Okay? Or we could have cut it this way, where it would have taken the shape of the base of the cylinder, which is a circle. Okay, and then again, we could have cut the rectangular prism straight down, and then we would have had a square cross section. Or we could have cut it horizontally, and it would have taken the shape of the base, which is a rectangle. All right. Number 23, we have to write and solve an equation to find the value of x. Now, when you complete this problem on your test, you don't want to use your protractor because that's not what they're asking you to do. We have a complementary angle. We have a right angle that splits into two angles, which are complementary angles. So we know that they add up to 90 degrees. So the equation would look like x plus 3x plus 10 equals 90, because we have one angle plus the second angle. We would combine like terms. 3x plus x is 4x. Then we want to subtract 10 from both sides, and we are left with 4x equals 80. Then we're going to divide by 4 to get rid of the 4, and we're left with x equals 20. Okay, now it's asking us to find the measure of angle LKM, which is this angle. So that means we got to take x and we got to plug it back in right there. So we'll have 3x, which is 20, plus 10. 3 times 20 is 60, plus 10 is 70 degrees. Okay? So you would want to do the same thing for problem 25, except we have a supplementary angle for problem 25, which means 4x plus 20 would equal 180 instead of 90. And then you would still use the same steps to solve for x. So you would start by subtracting 20 from both sides and then dividing by 4, which would be 40. And then you have to find the measure of angle ABD, which is this angle. So we would take 4x and substitute 40 for x. And we would get, well, 160. Okay. So now we're given this diagram for 27 and 28. And we have to first use ABCD to define the angle relationships. So first we have angle AFB, which is this angle here. And then we have BFC, which is this angle here. And the angle relationship between them would be complementary because of the fact that this whole angle is also 90 degrees. Then we have angle AFB, which is again the pink angle. And we have angle BFD, which is right here. The entire green and yellow area. And the relationship between these angles is supplementary because they sit on this straight line. So that means we know it has to equal 180. Okay, next we have AFB, which is again the pink angle, and EFA, which I'm going to highlight in purple. Okay, and these are also supplementary angles because the straight line that they fall on is right here. Okay, you just kind of have to rotate your paper and see it maybe right side up. But they do sit on a straight line, which makes them supplementary. And then lastly, we have AFB again, the pink angle. And we have EFD, which I'll use blue, I guess. EFD. Let me erase all these other colors. Angle EFD is right here. And these would be vertical angles because they are opposite of each other. Okay, they form that X shape. Okay. Now we have to use the information to find the measure of each angle. So the first one we have to find is angle CFD, which it kind of already gives to you because of the box. We know that this is a right angle. So this would be 90 degrees. Then we have the measure of angle AFC, which is right here. Well, these two angles sit on a straight line, which makes them supplementary. And if one of them is 90 degrees, well, that means the other one is 90 degrees because of the fact that they have to equal 180. So this one would also be 90 degrees. Then we have BFC, which I'm going to use yellow. BFC is right here. Okay, and we see that it's complementary to this angle right here that equals 36 degrees. Complementary means they add up to 90. So we would have to do 90 minus 36 to find the angle BFC. Well, 90 minus 36 is 54. Then we have angle DFE, which I will use purple for. Angle DFE is right here. Well, we know that this angle is vertical to this angle. And this angle is 36 degrees, which means DFE is also 36 degrees. And last but not least, we have angle AFE. And angle AFE is this large obtuse angle right here. And we can use that 36 degrees right here because we knew from problem 27 that AFE and AFB are supplementary angles, so they add up to 180, which means I would have to use 180 minus 36 instead of 90 minus 36. And I would get 144 degrees. Okay, and that's all I've got for you all. I hope that helps with trying to understand problems for the test tomorrow and to help you get through the Edulastic test review for today. Please email me or leave a question in the Google Stream if you have a question for me. I can make the time to Zoom or um, go over any other problems with you all. But please, please, please let me know if you need anything from me. Otherwise, I will see you all tomorrow for your exams.